Hello everyone, and welcome back to Revit Snippets. Great tips you can learn in just a few minutes. This video is brought to you by Tagitize, the easiest way to run tag all on multiple Revit views and sheets. Also, say goodbye to overlapping tags. Tagitize will turn this into this. Try Tagitize completely for free using the link in this video's description. We have a Revit model with lots of rooms inside, but today's tutorial will work with spaces as well. As you can see, each room's location point shows up as a red cross mark. For several rooms, this point isn't at the room center. This will be problematic when we, for example, tag those rooms, because Revit will place room tags at room location points if we use tag all. This means an off-center location points would result in badly aligned room tags. Not to worry. I'll show you today how to write this small Dynamo script to quickly move those location points back to the center of the respective rooms, areas, or spaces. To prove that it works, let me click Run now. And there we go. The script has instantly moved the location points of all those rooms to the respective center points. Let me undo and redo a few times now so we can see the improvement clearly. If you don't have much time and just want to run this script right away, simply find in the video's description a link to download this script directly. If you, however, want to learn to code this yourself, let me show you how right now, step by step. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's begin. To start, let's create a new script in Dynamo. I will now add a Python node to the graph and open it for editing. However, this is not a good script editor, so I'll type the code out in Visual Studio Code instead and copy it back into Dynamo at the end. If you're new to this workflow, don't worry. Just find in the video's description below a link to my other tutorial on how to set up this coding environment. It will also provide you with this Python template for Dynamo that will give you all the necessary information to then return to this video and start scripting with me. To begin, we need to create two supporting Python methods. The first one will project a point in 3D onto the XY plane. I'll call this method point to XY and let it take in a point input object like this. To do the projection, we can simply set the Z coordinate of this point to 0. However, we can directly set the existing Z value of the input point, so I'll create a new XYZ element instead. This new point will take the X and Y coordinates of the input point, but its Z value will be 0. Very nice. The second method will help us find the center point of a room or a space. I'll call it center point and give it a spatial element input object like this. Now, the quickest way to get the center of the element is by getting the centroid of its bounding box. To get the box, I can simply call getBoundingBox on the element, passing in a non-input to get the 3D bounding box and not a view-specific one. For some elements like unplaced rooms or redundant spaces, this will return a non-value because those elements don't have a valid 3D representation and therefore no meaningful bounding boxes. To handle those, let's check if the box is none, like this. If yes, we can just skip this element by returning none from this method. This means we eventually won't move these elements center points, but that kind of makes sense because these aren't valid spatial elements anyway. Next, let's get the center of the bounding box if it's valid. I can simply get the average of the box's minimum and maximum points like this. Now, it's important to check if this center point actually sits inside the room or space. In some spatial elements with irregular boundaries, this center point may be outside. If that's the case, we also shouldn't move the element's location point simply because its center point isn't valid. To check if the center is inside the element, I can use a condition depending on whether it's a room or a space. For rooms, we can check isPoint in room, and for space, it's isPoint in space. If that returns true, all is good, so I can return the center point from the method right away. If not, let's return a none value to let the script know that this room or space shouldn't be changed. All right, now that the supporting methods are ready, let's actually move something. To start, I'll collect all rooms and spaces from the active model using the filtered element collector we'll collect only spatial elements by adding this of-class call to the filter. Next, let's create two lists to keep track of the result. I'll call those done for successfully modified elements and skipped for those not valid for the script. To start editing the model, let's open a transaction like this. Remember to start it as well before the next step. It's time now to loop through all spatial elements we have collected with a for loop. For each element in the loop, we can check if it's an area. If so, let's skip it because we only deal with rooms and spaces in this script. Next, I'll first check if it has a location. If not, we'll add it to the skipped list and then simply skip it. Next, let's call the custom method we wrote earlier to obtain the center point of the element. For invalid elements, the method will return a null value. Therefore, let me add a condition like this to detect and skip those invalid items as well. To be fair, we can of course extend the center point method to handle elements with center points outside of boundaries as well. That will involve detecting the element's main horizontal surface and generating a grid of points on that surface. Then we can select the grid point sitting closest to the bounding box's center while still lying inside the boundary of the spatial element. We can easily do that here in this Python script, but I decided not to because that point strictly isn't the real center of the element. If you want to use the grid method though, just let me know in the comments and I'll add it to the script. If a spatial element has a valid location, I'll get its location point like this. Although it's rare, there's a chance that this point is already at the center of the element. To check if that's the case, I'll use the point to x, y method we wrote together earlier. This is because those points can have different z coordinates. As long as they share the same x and y coordinates, we can still consider them the same location for the purpose of this script. With all that said, the condition to write is simply this. If that returns true, we'll skip this spatial element as well. At this point, any elements left will need to have their location points moved to match the new center positions we require. To enable such a move, I'll need to compute a vector using the current and new location points. This is easy. Let's just subtract the points like this. Finally, we can move the element's location by the move command, using the vector as its input. All that's left to do now is add this element to the done list for reporting purposes and then commit the transaction to save changes to our model. Finally, I'll add both the done and skipped lists to the output of this script. Next, let me copy all text from this file, paste it into the Python node in Dynamo, save it, and close this node. Let's just run the script now to see it in action. Oh, we get an error. This is because my script was written in Visual Studio Code in Python 2 and not Python 3. This is easy to fix. Simply switch the Python engine here from Python 3 to Python 2. I can now run the script again. There we go. It works. Remember to review any rooms or spaces in the skipped list so you can adjust their location points yourself if necessary. Now that the elements have all had their center points nicely aligned, I can tag them using tag all like I showed you at the beginning of this video. For better results, however, use Tagitize. With Tagitize, you'll get the benefit of having some tags automatically moved outside the rooms if there are too many elements inside. This helps avoid tags being placed on top of room elements to help keep tags tidy and readable. That's especially useful for rooms like these stairwells where there's literally no space inside the room to place its tag. Even better, the app automatically detects the natural center locations of your rooms and spaces, so you don't even need to run this Dynamo script before tagging. That means if I can undo the Dynamo script run now and then launch Tagitize again. As you can see, it still tags my rooms and spaces at the correct center points, just like before, so it works great even without Dynamo involved in my workflow. It's even clever enough to avoid placing tags on top of other background elements, like those trees. If you'd like to try out Tagitize, feel free to use the link in this video's description. Alright, so there you have it. If you just want to run this script, there's a link in the video's description to download it. If you, however, want to master Python scripting in Dynamo, to create this kind of script yourself, check out my full online Python for Dynamo course, also linked to in the video description. If you like this lesson and want more like this every single week, make sure to subscribe to this channel now. For now, have a good day and I'll see you in the next tutorial.